So this question asked me to solve for the trigonometric ratios using unit circles. So the first trigonometric ratio that was given to me was cos 5 pi divided by 6, and I knew that 5 pi divided by 6 is equal to 150 degrees because I previously had memorized it from the unit circle. So I knew that my angle in standard position was going to be 5 pi divided by 6, or 150 degrees, and the related acute angle is going to be 30 degrees. So I knew that I had to draw a 60 degree, 30 degree special triangle. And then I divided all of the sides by 2 in order to make my hypotenuse equal to 1, and I had to do that because in a unit circle the radius is equal to 1, so therefore my hypotenuse would have to be equal to 1. And then I just did cos of 5 pi divided by 6. So it would be adjacent over the hypotenuse. So the adjacent side to 30 degrees was negative root 3 divided by 2 over the hypotenuse, which was equal to 1. So therefore, cos of 5 pi divided by 6 is equal to negative root 3 divided by 2. The next trigonometric ratio was the cosecant of pi divided by 3. And I previously knew that pi divided by 3 is equal to 60 degrees because I had memorized it. And for this one, the angle in standard position as well as the related acute angle is going to be pi over 3, or 60 degrees. So I knew that this special triangle that I had to draw had to be a 60 degree, 30 degree special triangle. And again, I divided all of my sides by 2 in order to make my hypotenuse equal to 1. So for this one, it was the cosecant of pi divided by 3, so it would have to be the opposite of sine. So instead of opposite over hypotenuse, it would be hypotenuse over the opposite side. So my hypotenuse was equal to 1, so I had 1 divided by the opposite side to pi over 3, which was root 3 divided by 2. And then I further solved and I got 2 divided by root 3, and because there can be no radical in the denominator, I had to rearrange. So therefore the cosecant of pi divided by 3 is equal to 2 times root 3 divided by 3. And lastly, the last trigonometric ratio was the cotan of 3 pi divided by 4. And I knew that 3 pi divided by 4 was equal to 135 degrees because I had memorized it. And then I drew my unit circle, and I knew that because this trigonometric ratio had an angle in standard position at 135 degrees, then the related acute angle would have to be 45 degrees. So it would have to be a 45 degree special triangle. So then I divided all the sides by root 2 so that my hypotenuse could be equal to 1. Because again, the unit circle has a radius of 1, so therefore my hypotenuse would have to be equal to 1. And the cotangent of 3 pi divided by 4 is the opposite of tan. So instead of opposite over adjacent, it's going to be adjacent over opposite. So the adjacent side to the 45 degree related acute angle is negative 1 over root 2, and the opposite to the 45 degree is going to be a 1 divided by root 2. So therefore I'm going to get 1 over root 2 negative divided by 1 over root 2 positive. So therefore the cotan of 3 pi divided by 4 is equal to negative 1. Okay, so this question asks about the intersection points of a primary trig function. So to see what is true about the points of intersection of a primary trig function and its reciprocal, I started off by looking at y equals cos of x and y equals the secant of x. So in order to find these points of intersection, I set the y values equal to each other. Then I put the secant function into its reciprocal form, and I wrote secant of x as 1 over the cos of x, and I multiplied both sides by cos of x and got the cosine squared of x is equal to 1. Then I square rooted it, and I got cos of x is equal to plus or minus 1. And so then I know that y is equal to plus or minus 1. So this then led me to believe or prove that a similar answer is seen for other primary trig ratios. So it must be true that the points of intersection of a primary trig ratio with its reciprocal occur at angles for which the y value is equal to plus or minus 1. So this is the case because if y values of, here I have an example of f of x, and y equals to 1 over f of x are intersected, f of x would equal to 1 over f of x, and f of x to the power of 2 is equal to 1, and f of x equals plus or minus 1, which tells me that a function and its reciprocal intersect only at the values of x for which f of x equals to plus or minus 1.